This is Eugene Mime with RedShiftBio, and I'm going to provide a quick introduction to the AQS3 Pro, which is a new type of instrument that is used for biophysical characterization of proteins. This is the instrument that Steve used in his experiment, which you'll hear about in the second part of this webinar. So as I mentioned, the AQS3 Pro is a new type of instrument that is being used now for biophysical characterization of proteins. Many tools currently exist that cover different types of measurement, like CD and FTIR for structure, DSC for stability, CC for aggregation, and V for quantitation. But industry is never one to sit still and demanding the ability to measure over wider concentration ranges, to have greater sensitivity to see smaller and smaller changes, the extraction of better and more usable or actionable data with each measurement. All this in addition to demand for simplifying the workflow, not just in prep and test, but also in analysis. So we developed the AQS3 Pro to address these needs. It performs 5 key measurements in a single analysis. You see some of them here on the right: aggregation, quantitation, stability, similarity, and structure. It performs this with 30 times the improvement in sensitivity when compared to conventional IR methods. It has the widest concentration range of any platform. We're routinely able to measure between 0.1 to over 200 mg per mil. And it has an integrated multi-sample capability using a well plate design for up to 20 times savings in direct labor costs. And finally, it has an automated and integrated protein analytics software suite, which is able to provide all level of detail, satisfying the needs of operators through scientists. The AQS3 works in the mid-IR, where it probes the vibrational modes of the carbonyl bond in the protein backbone. And this reveals spectral signatures, which are mapped to the secondary structure of proteins. Some of those are shown on the bottom right here: alpha helical structures, beta sheet, for example. And this technique is very powerful. It's been long recognized as a very effective method for the analysis of protein structure. But it hasn't been fully exploited because of constraints in the conventional IR methods available to date, particularly for aqueous solutions. So we developed a new platform, a new technique called Microfluidic Modulation Spectroscopy, or MMS for short. And it's really built upon 3 key components, which are shown on the left: a tunable infrared laser, microfluidic referencing is performed with a fluid cell, and the third piece is our advanced analytics. And so these 3 are integrated together onto a platform which basically works as follows. On the right here, you see a schematic that basically shows laser absorbance spectroscopy. Our source here is our tunable laser instead of, say, a glow bar, so it's extremely bright. It allows us to use a much simpler detector, a T-cooled detector, and in between we have our fluid cell. Now this cell is actually designed with 2 inputs, one for a reference fluid and one for a sample fluid. And these fluids actually modulate back and forth, typically between 1 and 5 times a second. And this is performed in order to achieve background subtraction. So we're able to do this very, very quickly and very timely. And this is possible because of the geometries of our microfluidic cell. And all of this is choreographed with our integrated software. So it coordinates the activities of our tunable laser with the modulation of the fluids and is able to construct a very accurate and very repeatable spectral profile for all our measurements. So all those put together allow us to achieve a sensitivity which is about 30 times better than conventional methods, all while simplifying the actual operation. We've tried to take the user out of the measurement as much as possible here so that measurements are very, very consistent and repeatable.